Hello everyone. Can you hear me? Hello. Can you, somebody in the chat, just let me know if you can hear me. So welcome to the Safety Artisan webinar, or one of a series of webinars. I'm not getting anything yet, so let me just check that my mic is working. Yeah, it seems to be. Okay, you should be able to hear me. So, first of all, thanks for dialing in. It's Anzac Day today here, so in Australia. So I'm wearing my poppy with rosemary thank you, Preben. Rosemary for remembrance. It smells very nice, but that's not what today is about. So let's get on with business. I'm going to share with you. In fact, I think I'm about to sneeze. So, no, I'm not. I'm okay. Okay. If I stop, you'll know what's happening. So I'm going to share my screen with you. And we've got presentation for you today. There we go. So what we have a webinar today on HAZOP and SHARD. And so that's hazard and operability analysis and software hazard analysis and resolution in design. I might have got that slightly wrong, but anyway, the meaning's the same. And basically these two techniques, in fact, I'm going to talk about a third one as well, all are similar, and they're talking about flows of stuff between nodes. Okay, so they're flow and node analysis techniques. That's just something that I invented. You won't see that anywhere else. So first of all, in our webinar, I've got a few things to get us set up and going. So as you saw from the video that we started with, the little recording, I'm thinking of 6 sets of people when I'm doing all my training courses and webinars. So I'm thinking of people who want to pass an interview, and I've had some really nice feedback from people about listening to the Safety Artisan got them an interview for a safety job. And so for that, you're going to need some knowledge, because even if you haven't got experience of doing the job, you can still have some knowledge to get you started on the ladder in the beginning. And of course, you need some confidence. So that's very important in an interview. So hopefully, if you've got some background and some knowledge, I'll have given you some confidence that you can use to good effect in an interview. Secondly, I'm here to upskill people. So all of these webinars are about tools and techniques. A lot of my courses are about how to do things in system safety and safety engineering. So it's all about upskilling you. And then hopefully that will help you get promoted, or it will help you change your career. So let's say you're not in safety and you want to be in safety. Well, that's the situation that I've been in. I was in sort of ordinary engineering, if you like, mechanical aerospace engineering, got into software accidentally, then got into safety accidentally. Well, with that experience, I hope I can help you. So to get promoted or change your career, you're going to need a combination of those skills from 1 and 2. Then in 5th place, maybe one day you want to transition to management. And management is often underrated by people and talked down, but it's actually quite a skill. And I was very lucky. I was trained to be a manager very early in my career, and it requires a new outlook and it requires new skills, mainly communications. Okay, management is communication, really. And so hopefully by learning some how we do business, you'll be more confident in your communication skills. And I can hopefully get you to avoid some of the pitfalls that I see engineers making, because as engineers, we love to fix problems. We love to dive into detail. That's not always helpful when you're in management. We don't want to be rushing to fix problems. We need to listen to people first and find out what is really needed. And then finally, maybe one day you want to become a director. So there are special responsibilities of being a director. Certainly in Australia, they are legally enforced. They're called due diligence. And of course, you need leadership as opposed to management. The two are not quite the same thing. Okay, so it's about direction, knowing where we are, knowing where we need to be, and having an idea of how to get there. Okay, that's leadership. So those are your 6 use cases or sets of learning objectives for what I do. And there will be, you'll probably notice there are different kinds of learning objectives scattered through the webinar. So a quick word about me. I've been in system safety for 25 years now, practicing, and I've done a lot of different stuff. I did 20 years in the Air Force, so I did lots of different aircraft stuff. Okay, but since 2012, I've been in Australia and I've worked on ships and submarines. And in all that time, I've worked on sensors and command and control systems, a little bit of stuff on rail and air traffic management, and lots of software safety. So I've done a lot of different things. And hopefully that means I'm not going to give you a narrow one domain view of things. I'm going to be able to talk about how things are done in different industries and in different domains, which is important, particularly if you want a job mobility and you want to keep moving around. So that's all very well, but today we're going to be talking about 2 or 3 tools or techniques. They're all very similar. So we're going to be talking about the contents of the webinar and how we're going to conduct them. I'm going to talk about HAZOP studies, and then we're going to have a QA session on that. I'm going to talk to you about some resources, including a little guide that I've taken off the internet and updated. We're going to talk about software hazard analysis. There we go, that's the correct word. Software hazard analysis and resolution in design, or SHARD, okay, which is much less commonly found on the internet. And also, it's a very similar thing, you might hear it called computer or control HAZOP, or CHAZOP for short, okay? And then we're going to have a final Q&A session. So that's what we're going to do today, tonight for me, maybe this morning or lunchtime, wherever you are. So let's move on. So I'm presenting just a little overview. Sorry, I'm not going to be going into huge detail on the technique or going into all the background, because that's in the guide, which I can send you. So as I'm talking, if you think of any questions, please put them in the chat straight away. I won't see them while I'm presenting, but when we get to the Q&A session, I will. If you can't put stuff in the chat, and depending on what platform you're on, not everybody can, you can email me at admin@safetyartisan.com, or you can text me on my mobile on 0431676809, and I've got it here. The mobile and the email will be available to me. So if you've got a question, I will answer it live. Okay, and if you don't want me to identify you in the answer, just put that at the top of your text, or you want to be anonymous. Okay. So I will respond, as I say, in the webinar for everyone's benefit to answer your question, but everybody else doesn't need to know who asked it. And I can promise you that all questions will be answered respectfully. There's no such thing as a silly question. However basic you think your question is, just go ahead and ask. I guarantee you there'll be other people on the call who were thinking the same thing and are really relieved that you asked the question that they were too hesitant to ask. And it says, ask me anything about safety engineering. So let's start with hazard and operability studies. So as I said before, fundamentally, we're analyzing the flow of things, whatever they might be, between nodes. Okay, and we'll see why that is in just a minute. I'm going to talk about the history of how HAZOP started very, very briefly and how we apply it. Talk about the process, the conduct of the HAZOP itself using the guide words, the advantages and disadvantages, and then actually we'll go through an example. And actually going through the example will clarify things, believe me. Be a lot more help. So fundamentally, we're talking about a flow of something from stuff from A to B. Okay, so we've got these nodes that we've marked. We've got an identified flow between them, and that might be physical stuff. It might be chemicals. It might be electricity. It might be data, or whatever it might be, we can analyze it. So we look at every flow between every node in the diagram. Typically, we're using some representation of a system that has boxes connected together or circles connected together. And you can apply this to almost any representation of a system that you can think of. And so we look at every flow and we look at every possible deviation from the desired flow, from the intent, okay, using guide words, right? And we'll come to those guide words in a moment. Now, the reason that this technique came about was it was invented by a firm called ICI in the UK back in the 1960s. And ICI is Imperial Chemical Industries. So they made huge amounts of chemicals in big chemical plants. So lots of reactors, lots of stuff, lots of pipe work, like you see in the illustration. And so, it sounds, talking about flow from A to B sounds very simple, doesn't it? Easy peasy. Well, actually, once you get into the real world and you've got lots and lots of connectors, lots and lots of pipe work, then it becomes much more difficult. And so we need to represent this big chemical plant or whatever it is we're analyzing, and then we need to abstract from the detail and then to look at the flows. So that's the history. That's how it started. It started with chemical plants, but since then it's been applied to all sorts of things. People have realized that you can apply it to just about anything. And it doesn't have to be a steady flow of something. It works for batch processing as well. So you can make a bunch of stuff, whether it be a chemical or a bunch of stuff on a production line. You can send that through and process it, and then you can do another batch, maybe even of something different or a different process. So you can do all of that in HAZOP. It's a very, very flexible analysis technique. So if we look at the process, and this little diagram is taken from the UK Health and Safety Executive website, which is a very useful website, lots of good information on there for free. And in their guide on how you should be doing HAZOP, they actually point out, and this is very helpful, there are different stages for a HAZOP study. Okay, it's not just doing the analysis in the table. Now, so the HSE suggests that you should first identify major hazards and check for the availability of hazard data that you want to look at. Now, having said that, you can do a simplified HAZOP to identify the hazards in the first place. It's sometimes called a HAZID or a HAZOP 1. Okay, so you can do a multi-stage HAZOP. So you might then choose to do a course HAZOP using a flow sheet and block diagram. Okay, and that's a good thing to do if you are the moderator. Okay, so if you've got to lead the HAZOP or support it, nice bit of preparation. Let's look at the system fairly coarsely in order to get an idea of what's what. Okay, and that will help you understand the system. As we'll see, it's very important for the moderator, the leader, to understand the system. And also, of course, if you've done a course HAZOP or a hazard ID HAZOP to start with, that'll inform you for the full HAZOP. Okay, now the full HAZOP, it says, should be undertaken on, it says, a frozen P&I diagram. So it's frozen as in the design is frozen. Okay, so it's not going to see major change, because otherwise your HAZOP results become useless. And P&I is piping and instrumentation. Okay, so that's the terminology for a chemical plant. But as I say, we can use any kind of diagram where we've got stuff or information flowing between boxes or nodes. Okay, so we do the full thing with the whole, all the interconnections. And on a major system, you could have a lot of people in a room for 2 whole weeks doing a full HAZOP. Okay, it can be a very big exercise, which is why a bit of preparation is going to make it go much more efficiently. That's important. Number 4, then, having done the HAZOP, we're going to generate a lot of actions, things that need to be investigated or done, extra controls maybe, the checks and balances. So we've got to check that they've all been done. The idea of this is done before we actually, build and finally install and commission the system. So we want a final pre-commissioning check, okay, to make sure that we've done everything we should have done, particularly if there's a statutory requirement, if the regulator has said you've got to do something before you can switch on. So that's very important. And then finally, you should do a safety audit after a few months of operation, just to see whether the HAZOP results were accurate, whether we've overestimated some problem or maybe we've missed something. Okay, so a piece of follow-up work is really good. Okay, and I think that is some very helpful guidance, getting you to think about preparation and thinking about what you do afterwards. Because actually, just going into the room and doing the exercise in isolation isn't always very useful. Okay, we'll talk more about that later. So we've got some guide words here. So when we're thinking about our flows, so we've got the normal flow that we intend, and then we think about, well, no flow, or it's not happening, or we think about more, we've got too much, or less, we've got not enough, as well as, so maybe something else has got mixed in with the flow. What could happen there? Maybe we've got part of the flow, so this might be a batch thing. Maybe we're getting some components but not others. Maybe the flow is going the wrong way entirely, for maybe pressure has built up somewhere, or low pressure back in the system, and that's caused a reverse flow or gravity or whatever it might be. And then we can think of other than, so that's as opposed to as well as, where we've got maybe corruption or something else, as a foreign stuff has got into, outside stuff has got into the flow. Other than, we've got a different flow entirely. So instead of water, we've got petrol or something else. And maybe if it's not a continuous process, if it's batched, maybe the stuff has arrived too early, maybe it's arrived too late, maybe it's arrived before it was needed or after it was needed. So we can tailor these guide words as appropriate for the application. Okay, and we can add more if we need to. Okay, so this is where a bit of preparation before we do the HAZOP saves a lot of time. Okay, that's important. And I'll keep making that point. because whether you're doing a HAZOP or commissioning one, I've been in a position as a consultant where the firm that we're doing the job for wants to save money, so they're constantly squeezing us to do less work, do it quicker, less preparation, etc. Actually, that's a false economy, okay? Because doing a HAZOP, getting all those people together is expensive. So if you skimp on the preparation, you're not going to get the full benefits of the HAZOP. So you potentially wasted a lot of money. So a little plea on behalf of consultants everywhere: do allow the people who are running this, do allow them to prepare thoroughly, do allow them to ask questions and get the information they need. It really will pay off. So advantages of HAZOPs. Let me just have a... So they're used all over the place, which means they're well understood and well known. Although actually, I think sometimes HAZOPs are too well known. I've done at least one job where we were doing a HAZOP for no reason that I could discern, except that the ultimate customer had put it in the contract. They'd obviously heard of a HAZOP and they wanted one. What we were supposed to be doing, I still don't know to this day. And it was a very long and tedious week, I can tell you. We got some results. How much use they were ultimately, I do not know. But anyway, so understand what you're doing. Don't just slap on a HAZOP for the sake of it. So it's good that we use the experience of operating and maintenance personnel as part of the team. That's really great. And in fact, certainly in Australia, it's a legal requirement to consult with workers. So that's good. It's good that we can demonstrate that. It's systematic and comprehensive because we're looking at the whole system. We should identify pretty much all of the hazardous deviations from design intent, and we should also spot operability problems, probably more operability problems than hazards. But that's good because it's going to make the process more efficient. It's going to save money in the long run. And of course, if we're investing in a great big industrial plant, then the cost of the HAZOP is trivial compared to the amount of money you can save. So we can look for both technical faults and human errors, or erroneous human behavior, as we say these days. We can recognize existing safeguards and recommend new ones and extra ones. The team approach means that we get several different disciplines or organizations to interact, which can be challenging sometimes if there are personality issues or there's a bit of friction between different parts of the organization, which is not unusual. So part of your job, if you are the moderator or leader, is to be a bit of a diplomat and try and get people to work together, play nicely. It helps us assess hazards ideally before the system becomes operational. I mean, I still think it's worth doing even if the system has become operational and you're having problems. You can still get a lot of benefit. Okay, you won't just fix the problems that you have already emerged. You'll find a whole lot more as well. Okay, and it helps us to derive corrective and preventative measures. Okay, so that's all great stuff, good stuff. So there are some disadvantages. So as I've already said, success depends on the facilitation of the leader and the knowledge of the team. And the leader does need some knowledge of the subject matter. Okay, that really helps because you could otherwise you can waste a lot of time on explanations and misunderstandings. Okay, now the technique is optimized for process hazards, so for the process industry, oil and gas, mass production of stuff on a production line, stuff flowing through a process repeatedly. Okay, so it's great for repetitive process not so good if the process changes all the time, or it's novel. That's not going to work very well, if at all. It is very repetitive, but you need that repetition. You need to be systematic and complete. So that repetition is necessary. Once you get into it, and particularly if you've done some pre-analysis, you will spot that, oh, okay, this is a carbon copy of the one we've just done, or it's the opposite of what we've just done, or it's a variation on something we've seen before. And you can carefully copy and paste previous lines into the line you're working on, okay? But do be careful about doing that, because otherwise you can make copy and paste errors. Now, documentation can be lengthy if we're doing a complete recording of everything, okay? But of course, you know, if we're looking at a big expensive plant, that's worth it. So the method is labor intensive and time consuming, but again, it's worth the investment, or it is if you understand the return you're going to get. Okay, so why are we doing? Why do we need to do this analysis? Okay, if you can answer that question, and then it will be worth it. Okay, and it may not provide adequate design solutions. To be honest, it's not intended to. It's an investigative method. So if you come up against the problem that the team can't come up with a solution there and then, you may have to do an action to say, this needs further investigation. We need to look at our options. Okay, but that's a good thing. You know, you don't want to be trying necessarily to design everything there and then. You can make a lot of mistakes or miss opportunities. And probably the most limiting thing, it really focuses on identifying single failures only. So if there is a possibility of a cascading failure or a common cause failure, this technique is probably not going to find it. Maybe experienced practitioners will notice that, maybe not. Okay, so if cascading or non-independent failures, common cause failures are a concern, then you need to apply a common cause analysis technique as well to complement this one. Okay, so HAZOP only does single failures. Right, so let's look at an example. What we're going to do is look at a very simple HAZOP where the ship on the left is a tanker or a replenishment ship, and it's doing refueling at sea of a warship in this case. So the ship on the left is transferring fuel, liquid fuel, into probably diesel into the ship on the right. And so we've got a picture of the real thing with all of the detail, and then we've abstracted away from all of the detail, which we don't need and will just confuse people. And we've got a nice simple diagram. So that's point number one. We need that abstraction. And what I'm just going to do now, I'm just going to stop sharing this. And, oh, you can still see the first slide. Did you get to see, everybody, did you get to see the subsequent slides? Or were we stuck? Okay. No, so you didn't, right. Okay, sorry about that. What I will do then, I'm sorry, I will whiz through again very quickly. I do apologize, that is annoying. Right, let's try again. So, well, yeah, you don't need to look at that again. Here are the topics that we are going to look at. As I went through them, we're going to do HAZOP, SHARD, and CHAZOP. Those are the ways to contact me. If you put your questions in the chat, or email admin@safetyartisan.com, or send me a text on, if you're in Australia, 0431 676 809, and it's +61 for Aussie if you're abroad. So we've talked about all of these things. Basically, we're talking about flow between two nodes. As we've discussed several times, it's come from identifying flows in pipe work, starting in chemical plants. We've got a little bit of guidance on the HSE website, well worth looking at, by the way. We've got some guide words. I'll send you the slides anyway in a PDF. We've discussed the advantages, the disadvantages, and we're on to our example now. So I'm very sorry about that. Let's get back to you're welcome. So I'm going to share, I'm going to look at the guide now. So bearing in mind, we've got the, okay, so we should see the guide now. So in the guide, I will just, for your benefit, and again, this is a PDF. What I've done, this is a PDF from the UK MOD system, and it's, I'm allowed to do this. Don't worry, I'm not infringing anybody's copyright. So we've got all of the background here in much more detail than what I've given you. We've got all the advantages and disadvantages. Now, what we have here is some links to various standards and things that can help you. And I've updated all of these links, okay, as of a couple of days ago. So, because they were all out of date. There's the picture that we've just seen. So we're refueling the ship. And then there's some more background on there, which you would need in order to understand what was going on, okay, and to do the analysis. So that's a nice illustration. You need some background information if you're not already an expert on this stuff. And even if you are an expert, the danger is that, you know, things move on, okay? So you might be an expert in the old system, but if you're looking at a new system, things might have changed. So it pays to read the briefing. So what we end up with here is a typical sort of HAZOP table. This is a tabular process. And because it's invented in the West, it reads top to bottom, left to right. Okay. Now, if that's not how your alphabet system works, or you're working with people who don't read that way, then obviously you can swap stuff around, because as we go through it, you'll see we're working from left to right, because that's, you know, that's the way Westerners work. Okay. But there's no problem with you swapping it around if that's not how your language works, or how your customer works. So we've got lots of stuff at the top here. What are we talking about? Some general information about the document, which is all good stuff. We need that. Who led, who was recording. You should always have a separate recorder or note taker or secretary, so that the leader doesn't have to do that. Again, you may come under pressure to skimp on this to save money, but it's a really bad idea. Don't do it. So, because you can't do both jobs well. Okay. I wonder if somebody has sent me a... All right. So we've got what's the project? What node are we talking about? In this case, we're talking about from the connection from the tanker to the ship. What are we trying to do? What's the design intent? Well, we want to pump fuel from the tanker to the other ship. What are the normal process conditions? So that's good. This is what good looks like. Actually, it says 3 bars. It should be 3 bars. I don't know how that happened. Who was present on the team, which is very important. Did we have a suitably qualified and experienced team to do this? which is all good stuff. You can't add this stuff in afterwards. Okay, so make sure you record it all. And then we start looking at what we're going to do. So we would typically have these kind of, you do see variations in these tables. What's our guide word or deviation? Okay, no flow or none in this case. What might cause that? What are the consequences? What are the safeguards that we can think of and that are already there? And are there any recommendations for further work? So for this one, for example, we've got no flow. Why might that be? Well, the manual valve on the pump inlet might be closed, which means no transfer of fuel. The pump gets starved of liquid, which could damage it. And it may be that we end up with leakage from the pump into the sea, or if there's an ignition source, we could get a fire. Now, in this example, I don't think this has been written very well, because all of these different consequences are all lumped together. In my view, put them all on a separate line and number them separately, okay? And because you might have different safeguards against different consequences, okay? So, okay, operator knowledge and training, that's pretty universal. A local stop if the pump leaks, okay, well, that's to deal with leakage. So if we've numbered all of these, let me start again, what is this? If we've numbered all of these consequences and then we number, we've got the first one works for all of them and then this one just works for number 3 or whatever it is, make it crystal clear what relates to what, because somebody might have to come back and look at this in 10 years time and it might be obvious to you at the time what you meant. It won't be to them. So really work hard to make it crystal clear, go over the top on clarity and simplicity. And here we've got a recommendation. Okay, provide a cutout that stops the pump if it's running dry or the liquids are too low a level to prevent pump damage. Great. Okay, or I suppose you could have a pump that doesn't get damaged by that, but probably that's much more expensive than this. So there you've got an example following it through. So, and here we've now got different causes. So we've got a different line for each cause. Manual valve on pump outlet closed. Okay. Does similar things, no transfer of fuel, pumps running against closed, which could cause it to overheat, mechanical damage, etc., etc. Some safeguards and another recommendation here. And then, we've got a blocked line or filter. Okay, same results as above. Now, okay, so it says line or filter blockage is unlikely since fuel delivered is clean. That's an assumption, okay? So if you're going to make assumptions like that, put them over here. You might say check the filter periodically or before each transfer, okay? Or there might be some other recommendation. So there's one example of no flow with 3 causes, multiple consequences, etc., etc. So as you can see, very quickly, we're teasing out a lot of information, okay? And then we get on to reverse flow, more flow, and that's it on this example. Okay, we've only got effectively one page of work, but it does illustrate how it all fits together. It illustrates the process, okay, the technique, and it's a very powerful process. So really, really useful. A lot of information to record, but as I say, do be diligent about recording information, everything you can at the time, because it may become important later. This is a great audit trail, because not only could you say, well, I've done the analysis, but you can demonstrate if you've recorded the team members who were present and their different specialities, you can show that the right people were involved and they were competent to do so. So that's very important. So I'm going to go back to the our slides. Okay, I said I'm going to go back. Now we're talking question and answer and resources. So while you're thinking of your questions, do fire them out. Just some resources for you. Those things that are in the guide, they're also in the slides there. Okay, so there's lots of good information on these sites. Enjoy. Right. So I'm going to stop sharing a mo, because then I can see whether I've got any questions. So any questions from anybody? I can see we've got a few people booked in by Eventbrite. We've probably got more on social media. Right, so the first question I've got here, can you elaborate on the difference between PHA and HAZOP? Okay, so really good question. There's actually quite a bit of overlap. Okay, so if you're doing a preliminary hazard analysis, maybe you're doing a functional failure analysis, or a FMEA, a failure modes effects analysis, or a FMECA, a failure modes effects and criticality analysis, there's going to be considerable overlap between that and a HAZOP. If you look at the tables for the different techniques, they look quite similar. Again, they work top down, left to right, looking at all the different possibilities. You go through the design systematically, so they're quite similar. Difference in emphasis. FFA is so PHA techniques. Actually, to be truthful, it should be preliminary hazard identification and analysis, because all of these techniques are really good for identification as well of hazards. Okay, so HAZOP, particularly a simplified HAZOP, is very good. A crude HAZOP, a coarse one, is very good for hazard ID. More detail gives you better analysis. Okay, but you're going to get similar results to an FFA or a FMEA. The difference is being an FFA you can apply when you don't even have a design, because it's only about functions. A FMEA, okay, you've got a design of a system, of a thing, maybe a preliminary design, and then the HAZOP, again, you might have a preliminary design, or you might be doing a full hazard on a frozen or a chilled design, let's say a more mature, detailed design. But it's differences of emphasis, really. They're not that fundamentally different. Okay. The reason you would choose a HAZOP is because you've got this flow going on. If you don't have that flow, there's no real reason to have a HAZOP. So great question. Thank you. Anything from anyone else? I'm checking the... Okay, I've not got any message. No, I'm looking in the wrong place there. Let me just check my emails. Okay, of course, they're all going to appear. Let me check the junk. Okay, I don't think I've got any emails. I don't see any more questions. Keep thinking about your questions. Keep sending them in. We'll move on. There'll be another opportunity to ask questions later. So I'm going to go back to the slides. And here we go. Good. So we're back to the slides. So we're going to talk a little bit about shard or HAZOP. And okay, so have we said what is shard? Okay, software hazard analysis and resolution and design. Basically, it's HAZOP for digital systems. Okay. Yeah, and shard does for digital what conventional HAZOP does for analog or mechanical systems. And all we need to do really is choose different guide words. Now, here's a suggested set of guide words from this website, and or in fact, this blog post on Medium. And I picked this one because it came out as top of the list on Google, and it's not sponsored, so that's usually a good indication that lots and lots of users are looking at this and recommending it and coming and linking to it. So this is good stuff. That doesn't mean to say it's the end of the matter. You could have different guide words, but you want to be thinking about the way software goes wrong, okay? Or digital systems go wrong as opposed to mechanical systems. Okay, so we might get no data, or we might get data update when it shouldn't, early or late again. The data might be out of tolerance. Now it says the wrong intolerance. I'm not exactly sure what the author of that meant by that. But you can, maybe you've got your tolerances set incorrectly. But there's other things you can add. So think about how your system could go wrong. So this is where maybe a quick functional failure analysis will inform you. Understand the way different digital devices can fail, or the way the software can fail, and then you'll have a much sharper analysis. Okay. But it's still very, very similar to HAZOP. Okay, so even if you start off with design words or deviation words that are not perfect, if you do a coarse one or you have a dry run, you'll improve that for your system. So here's an example. Don't pay too much attention to the labels in the boxes. I just picked this diagram because it's got several different boxes representing maybe different digital components or systems or equipments that are talking to each other on a network, let's say. Okay. Now the difference, of course, with a software shard is that software can't hurt anybody. So if it's just software moving data electronically around, okay, that can't hurt anyone. Now, that means that if you're aware that a certain part of the system, so I've got a swerving car there, which is meant to represent, let's say you've got a moving actuator, which your system is controlling. So we've got physical movement, we've got kinetic energy or potential energy, which could hurt somebody, or maybe you've got electricity, particularly high voltage electricity that you're controlling, that could hurt somebody, or maybe you've got radiation of some kind. You've got some sort of emitter pumping out radar or radio waves, or heat. So for those items where a real world hazard could be, you can start your search there and work backwards from there. So you could use the HAZOP, which is kind of counterintuitive, because normally we might think of, well, I'm going to start at the beginning of the process and I'm going to work through from beginning to end. And yes, that's a good idea with a HAZOP for an analog system, because the hazards could be anywhere. But if you've got a digital system and I'm controlling a radar, I'm controlling electricity, I'm controlling movement or pressure or something like that, and you've already identified these hazards, you can then maybe take a shortcut and work backwards from the hazard to see what could lead to it. Okay, which then means you don't necessarily need to analyze the entire system. Okay, you just start with the dangerous bits and work back from there. You've still got to work all the way back to the point where you go, actually, once I get to this point further back, nothing that happens back here makes a difference to the hazard over here, so I can now stop. Okay, so you still got to verify that you've done enough work, but you wouldn't necessarily need, we wouldn't necessarily need to analyze the sort of connections of some of the boxes over here with each other, okay, because they're not affecting these critical areas. So there's a little hint there that there's a different approach with shard. Now, having said that, with digital systems like a computer or a control HAZOP, let me go. There are some techniques, and I've gone back for the diagram. There are some techniques where you start by looking at the entire system and going, okay, what could go wrong with my entire system? What could go wrong with each subsystem? What are the common mode failures? Let's think about the hazards in general. And then and only then do we get down to the detail of looking at specific flows. Okay, so maybe with the digital system, we need to be a bit more diligent about doing that preparatory work. Okay, because software is intangible. So it's much easier to miss something. So in one sense, maybe a shard, we don't have to do as much in one sense, but we've got to compensate and do, and for the intangibility of the system, and do some more preparatory work. And I've certainly done that, and it's very helpful to understand the overall reliability and integrity of a system before you get into the detail of each individual flow or data path. Okay, and that's going to help you again focus your attention on where it really needs to focus. Okay, so because if you know you've got a highly redundant and diverse digital system, well, okay, we've already got a lot of protection measures built in. Whereas if you know you've got a system that doesn't have redundancy or diversity, okay, a single failure might be much more significant in this area. The other thing about thinking about a shard or a HAZOP, and what I've just described about doing the levels, that's captured in some HAZOP approaches. We might be using this HAZOP as part of a wider process, let's say in functional safety. So in the example on the right, we're doing a classical functional safety analysis as beloved by IEC 61508 standards and family. So the railway standards, the CENELEC 50128 and so 50129. 61511, those family of standards will get you to do this kind of sequence of different things. And maybe if you've well, everything has got digital controls these days pretty much. So having done a conventional HAZOP or a bow tie or whatever, before you get into your SIL determination, your LOPA, using whichever of the half dozen techniques you can use, maybe you need to do a HAZOP as well in order to fully inform that stage, and before you can verify your SILs and come up with your safety requirement specification. So again, HAZOP or a shard might have a part to play in a bigger suite of analyses. But of course, if you know you're doing that, you know the purpose of your HAZOP or your shard or your HAZOP, you know why you're doing it, so you're more likely to ask the right questions and get good results. But as it says in the final point, what are we trying to achieve with the technique? Okay, if you don't know, you're probably not going to get great results. Okay, if you do know what you're trying to achieve, that will help you to select the right technique, whether it's HAZOP or something else. Will also guide you to do the technique well. Okay, which is true of all tools. Okay, if we're using the wrong tool or we don't know how to use it, we're going to get bad results. This is why I get frustrated with people on social media who put clickbait about, oh, risk matrices are bad, FMEA is bad. No, it's not. A tool or a technique, if you're using them for the right purpose, you're using the right tool for the right job, and you know how to use it correctly, you'll get results. Okay, so there's no such thing as a bad tool. There's only poor workers. So I'll get off my soapbox now, because that's, as you can tell, that's something that really irritates me. So in summary, we've got this process. So here's a little flow diagram here. You'll see, if you search online, you'll see loads of different flow diagrams for HAZOP. So have a look at the different ones and see which one makes most sense to you. But in summary, we can do lots of different things with these techniques. We can do hazard ID, we can do hazard analysis, we can look at causes and consequences. We can do it at preliminary design and detailed design. And it looks at hazards and human factors and usability and sort of process efficiency things. Okay, so so it's important that we understand what we're trying to achieve. And yes, we can do all of those things, but in that case, then we need to design the overall process to achieve that, as the health and safety executive page suggested. So that would be my overall message to you. Don't just go, we're going to do a HAZOP. Understand what you're trying to achieve and tailor your process appropriately. Okay, I'll tell you what, we'll do the final QA session. I'll come back for questions. I just wanted to let you know the next webinars that are coming up. There are some of the ones that we've done. We started back in November with FMEA. And so today we've done HAZOP and SHARD. Next month it's event trees. And then we're doing claims, argument, evidence, and goal structuring notation in June, and fault trees in July. So that is what is coming up, and you're most welcome to join me. So you should see stuff come up on Eventbrite or on LinkedIn or Facebook. So do look up the Safety Artisan and follow me, please. And you can always go to the website safetyartisan.com, and if you subscribe for the free emails, you won't miss anything. You'll always get updates on what I'm doing, and you'll be told about what's going on. So that is the end of the slides. I'm gonna be all right. So we're on the hour actually, so that's good. So I'll just stop sharing that. Okay, so do we have any more questions from anybody? And I'm gonna switch the beast on. Okay, I'm not seeing any emails. Typical. I've got a text from Microsoft, but nothing from you good people. So any questions from anybody? Not necessarily just about HAZOP. If you've got any questions about safety engineering, system safety, do let me know, and I will just wait here to see if anything comes in. Okay. Well, I'm not seeing any more questions. If you think of something later, then I'm on LinkedIn, I'm on Facebook. You can leave me a comment on the website. I'm also on X, Safety Artisan, formerly known as Twitter. So it just remains for me to say to everyone, thank you very much for dialing in. It's always a pleasure to interact with other professionals and enthusiasts, and I hope the rest of your day is wonderful. Okay, take care, everyone, and I'm gonna